Hey guys, welcome back to the channel Learn with Art. Now our today's topic is equivalence of finite automata. Okay, so equivalence of finite automata means two different automatas are considered to be equivalent if they accept the same language even though they use different ways to do so. Means what? Two different finite automatas are equivalent if they accept the same set of strings or they accept the same language over the symbols present in set sigma. Okay, for single language we can draw multiple finite automatas that are equivalent. Okay, means for a single language we can have different transition diagrams. Means these are finite automatas accepting the same set of strings. Okay, so the way of representation of transitions as well as states are different. That's why these are two different finite automatas, but their motto is similar, that is they accept the same set of strings. Okay, so if two finite automata over sigma are equivalent if they accept the same set of strings over sigma. Okay, so directly we will move to example so that we have the better understanding for equivalence of finite automata. Okay, so here we have two different FAs, one is this and other is this. Okay, so I have also written transition table for these two. Okay, so I have written single table for these two. Okay, this left hand side symbols will represent the symbols of this left hand side DFA, and the right hand side symbols will represent the symbols related to this right hand side DFA. Okay, now we will consider, now we'll see. Okay, so here we have the Q1 initial state for this DFA and Q4 initial state as well as final state. We have Q1 initial state as well as final state for this FA and Q4 as initial and final state for this FA. Okay, so if we observe this transition table, then we know that if we supply 0 input to state Q1, then output state is Q1 and Q1 is my final state. Okay, the same case will repeat for this second FA. So if we supply 0 input to initial state, that is Q4, then we will reach to state Q4 and Q4 is also final state. Okay, so again we'll check it for other transitions too. Okay, so if we supply one input to state Q1, okay, one input to state the Q1, then it will go to state Q2. Okay, and same for Q4, if we supply one input, then it will go to state Q5. Okay, so here Q2 as well as Q5 both are non-final states. Okay, so here we'll observe that all these states are either final or non-final. Okay, so here we again see that Q3 is again my non-final state and Q6 is again my non-final state. Okay, so means what? If after reading one symbol, in case of this finite automata, if that state reaches to final state, then same condition will happen here. After reading the same symbol, it will again reach to the final state. Okay, and if it will reach to non-final state, then same situation will occur here, that the same it will go to non-final state. Okay, so the output transitions, output states, or the combination of state is final or it is non-final. Okay, so here we have final combination of state and here non-final. Okay, Q3 is again non-final, Q6 is again non-final, Q1 is final and Q4 is again final. Okay, so this is also non-final. Here again non-final and final combination. Okay, means what? If we observe, if we input the string 001 to this FA, what will happen here? So first it will read 0, then 1, it will go to state Q2, then after this 0, it will go to Q3, then next 0, okay, and then again 1. So after reading, the whole string will reach to final state, that is Q2. Okay, so same string we are inputting for this FA. Okay, so 0, 0, then 1, then 0, then 0, okay, and then 1. Okay, so after reading this whole string, we are going to state Q4, and Q4 is again final state. Okay, we will apply one more string. Okay, so 1, then 0, then 1, then 0, then 1, and then 0. Okay, so we are again at state Q1, and Q1 is again final state. We'll apply same string for this FA. Okay, so 1, then 0, then 1, then 0, then 1, then 0. Okay, so again applying of this second string will reach to final state. Okay, so means what, these two finite automatas, we can say that these two are equivalent FAs. Okay, now we'll see one more example related to non-equivalent states. Okay, so here if I have taken the first finite automata and this second finite automata, okay, and I have written the transition table for it. Okay, so again left hand side symbols will represent for symbols of this finite automata, and the right hand side symbols will represent for right hand side finite automata. Okay, so if we observe, if we supply 0 input to state Q1, then it will go to state Q2, that is Q2 is my non-final state, and again here for Q4 it will go to Q5. Okay, so that is again non-final state. Okay, so here we don't have any problem. Now next, if we observe 0 input given to state Q2, Q2 is non-final state, Q5 is also non-final state. Okay, so if we supply 0 input to Q2, then we'll go to state Q1, that is our final state, and here in case of Q5, if we supply 0 input to state Q5, then it will go to state Q6, and Q6 is not final state, means here we'll get one combination as final and other is non-final. Okay, so again we'll see one of the string will give input to these two finite automata. So if we read 0, 1, 1, 0 string to automata first, okay, so what will happen here, 0, then 1, then 1, and again 0 will go to state Q1. Will give string 0, 1, 1, 0 to this second finite automata. So 0, 1, 1, and 0 will reach to state Q6, and Q6 is not final state. Okay, so means after reading this string, we are going to state Q1, which is final state in case of first finite automata, but here we'll reach to state Q6, which is not final state, means this string will not be accepted in this finite automata, but that is accepted in this first finite automata. Okay, means we can say that these two are non-equivalent finite automatas. Okay, again we can have the same observation for this string. Okay, 1, 0, 1, 0, 1, 0. Okay, so 1, 0, then 1, then 0, then 1, and then 0 will go to state Q1. Okay, we'll observe the same string for this finite automata. So 1, then 0, then 1, then now we don't have any transition at Q7 for input symbol 0, so we'll stuck at Q7 only. Okay, means what, this string will not read by this finite automata afterwards. Okay, so we can say that these two are non-equivalent finite automatas. Okay, so these two are non-equivalent DFAs because after application of 0 to state Q2 and Q5 gives output state Q1 and Q6, of which Q1 is final state, okay, and Q6 is non-final state. So these two are non-equivalent finite automatas. Hope so you have understood what is mean by the equivalent of finite automatas and non-equivalence of finite automatas. If you have any queries, then please do comment and like, share and subscribe to my channel. Thank you very much.